Okay, so 4.1, we're going to work on the inverse part of this. Tomorrow we're going to work on reciprocal, and it's going to move in. The reciprocal function, guys, you learn this much this year, about 1 inch of it. Next year, you learn about 4 inches of it. And then in calculus, you do it again. So the sooner you learn the parts that I'm teaching, does it make the next time even easier? Yes. Please make some effort, guys, because I haven't seen a whole lot, and I would love to start seeing it. Okay, so it says graph the reciprocal function. We're just going to look at this for today. And state the domain and range. Maybe this is not the right slide show. Okay, it is. So we'll do this part and then we'll go on. So I have 1 over x, yes? Yes. And I said graph it, but I didn't tell you anything about it. So if I don't tell you anything about something but want you to graph it, is there a way to graph it? I gave you an equation. So should you be able to know how to graph it?
No. Not right now, but we
Really?
Eventually.
You don't think so?
No. I think so.
I do.
The way you're saying it, there's probably is.
Well, but what's x?
Well, can't you just pick an x?
2. 4.
Can you plug in, can I make a table of values?
Yeah.
Yeah. Okay. So I'm going to make evidently that's a really big coordinate plane. I don't know why the line is so thick. But anyway. Okay, so there's my coordinate plane. And I can make just an X Y chart, couldn't I? Now, this isn't very efficient, is it? To do it this way?
No.
No, it's not very efficient, but will it work? Yeah. Okay, so let's do it. We have X and Y. Okay, so we need to have some negative numbers and we need to have some positive numbers. Okay? So how about like negative 4? Oh, we're going to change that to 8. Negative 4, negative 1, 0. Does that sound good? Yeah. And then you guys want to do 1, 4, and 8? Just mirroring it, right? Did we do that when we did quadratics?
Yeah.
Yeah. So these are the x's, so I'm just going to plug them into that equation and get out y's, right? So if my x is negative 8, 1 over x would be what? Negative 1/8. And then the next one would be what? Negative 1/4. Negative 1.
0.
It would be 1 over 0. Can I divide by 0? No. So it would be undefined. What happens when I put in 1? 1. And when I put in 4, I get 1/4. And when I put in 8, I get 1/8. Okay, well. Well, when I put in negative 8, I get negative 1/8. So that's like really close to the x-axis, isn't it? Okay, well, when I put in negative 4, I get 1/4. Negative 1/4, which isn't much, right? And when I put in negative 1, I get what? Negative 1?
Yeah.
And then I had 1 is 1. 4 is 1/4, and 8 was 1/8. I really don't know what happens to this, do you? What would happen if I put in 1/2? Like negative 1/2? Because the reason I'm asking is, you won't be able to see that color. This graph is doing this, yes? Where does it have to go from here? How could it doesn't have a 0? Have we found a x-intercept? No. Because an x-intercept is where y is 0, right? Okay, so if I make this 0 equals 1 over x, well, I'd multiply by x, right? And I'd get 0 equals 1. Does 0 equal 1? No. So does this have an x-intercept? No. There is no x-intercept. So we're just using stuff we already know about graphs, right? So it can't go up. It has to go where? It has to go down. And we already know what happens when x is 0. It's what? Undefined. So it can't hit the y-axis either, can it? There's no x-intercept or y-intercept. Well, this one is going out like this, so it has to come from where? Up here, right? My tail shouldn't be here. Oh, no, it just ruined it all. It was so pretty. Okay. So what I was asking was, what happened when it was 1/2? Well, if I plugged in 1/2, that would be 1 divided by 1/2. Well, what happens when we divide fractions? We multiply by the reciprocal. What's the reciprocal of 1/2? 2. So it would be 1 times 2. So it would be what? 2. So at 1/2, it's up to 2. At 1/4, it'd be up to where? 4. At 1/8, it'd be up to where? 8. So did it come from over here? Did it come this way?
Yes.
Yes. Now at negative 1/2, wouldn't that be negative 2? At negative 1/4, it would be negative 4. And then negative 8. So it would come down. This is what the reciprocal function looks like. Without moving it left, right, up, down, it looks like this. That's what it looks like. You know what's an asymptote? Where it's undefined. And I'm not gonna say that's what it is today, because I'm just telling you what it is today, because we're gonna talk more about asymptotes when? Tomorrow. Okay, so this is an asymptote here. And this is an asymptote here, actually. And you'll learn how to find those. But this graph is never going to hit the x or the y-axis, is it? No. Now, what happens when we add our h and k into it, though? H moves it what? Left and right. K moves it up and down. Did you have your last question that involved h and k? Yep. Okay. I'm going to keep throwing those things at you because I am not giving you permission to forget. Got it? Okay. So that's a prequel. That's what's going up. So today, when a relation between x and y is an inverse variation, when it is an inverse variation, we say that x varies inversely as y. Okay, we say those words. When x is an inverse variation, we say x varies inversely. And I've always said 2y, so I'm really curious if it's 2 or as. Let me see. Yep, they say as in this book. I always have said x varies inversely 2y, but now you got to learn what an inverse variation is, right? So an inverse variation is modeled by the equation y equals k over x. An inverse variation is the equation y equals k over x. Looking at you four that aren't writing. Okay, you have to know that. On the ACT, they are going to say this and this are inversely related. So what equation should you be thinking? Okay.
Yeah.
Well, we know what an x is, yes? We know what a y is. You don't know what a k is, do you? K is the constant of variation. That is the number that relates the two variables in an inverse variation. So a constant, it could be a half, -1, 6. It's how things vary, okay? So we know what an x and y is. They're x and y, correct? Yes?
Mm-hmm.
And when you plug in an x, you get out a what? Y. So we would have to know what k is. So there's 3 variables, x, y, and k. So as long as I know how many of those, 2, I can find the other one. If I have x and k, can I find y? If I have x and y, can I find k?
Mm-hmm.
If I have y and k, can I find x? Yes. So I have y equals k over x already. That's the inverse variation. What would k equal? What math would you have to do with y equals k over x to have just k?
X and Y.
We'd have to multiply by, it would be xy, because we'd multiply by x.
Mm-hmm.
Okay. What would x equal?
K over Y.
It would be k over y.
Why?
Because you would multiply by x on both sides and then divide by y. Because you would have x, y equals k, and then you would divide by y. So x equals the reciprocal of what y equals, doesn't it?
Yeah.
Does that make sense? Okay. So from this inverse variation, can I find all 3 variables? Yes. If I say that x and y are inversely related and the constant variation is 6 and y is 4, can you find x? Yes. Is it always going to be a whole number? No. Your life is no longer whole numbers if you haven't figured this out by now. So that's nice and neat for algebra, but then it goes away. Okay, in an inverse variation, so the first thing you're thinking in your head is what? Y equals k over x. Anytime you read inverse variation, what are you going to write on your paper? Y equals k over x. X is 10 and y is 3. Write an equation to represent the inverse variation, then find the value of y when x is -6. So if I have x and y, I have to find what? K. Because k would have to be in an equation, wouldn't it? Okay, so y is 3 equals... Actually, can I move around the equation first? I like to move around my equations before I put numbers in them. Because what if my numbers are like big and I mess them up? Does that make sense?
Yes.
So I have y equals k over x, and I need k, so that means I multiply by x.
Y.
So I have x, y equals k. So now I just need to plug in x and y, right? So I have 10 times 3
30.
equals k, which equals 30. So it says write an equation, doesn't it? So I'm going to take my equation and fill in k. So y equals, what's k? 30 over x. So did we find an equation?
Yeah.
Okay, so we got the first part. There's A. And B says what?
The value of Y.
Find y when x is -6. So what am I going to do? Plug in -6. So I have y equals what? What's
30 over -6.
30 over -6. So y equals
-5.
-5.
Hey, not too bad.
You guys want to try on the next one?
Yeah.
Okay.
Oh, ew, it's gonna have.
Have fun. It's easy. Don't let the fraction scare you. You are bigger than it. You bite harder than it. I believe in you. I really think you can take half a 6.
I don't know. 4 is a pretty good
Some
number.
days I wonder. Can I start? You guys far enough? Did you do both parts of it?
Yes. What's the second part? I think I did both parts.
Okay, so did you get your K as 3?
Yeah.
Okay, so your equation. So when I grade these, I'm looking for your K and then your equation. So y equals 3 over x. And then you plug in 15, and your answer is 1/5. So I'm looking for all parts of that. Is that a very hard concept? No. What equation, when you hear inverse variation, do you need to think of?
Y equals K over X.
And I'm serious, guys. There will be one question on the ACT like that. I promise you.
I'm missing that question.
They do it all the time. Because is that really a hard concept, though? No. But people go, what? Huh? Okay. The inverse is the same as the reciprocal is function in this case. So,
Is that what we read it?
no, right here.
Oh.
And it's the, yes, that is all you are doing today.
So just
But this is
stop.
just a different way. Okay.
I don't wanna
So what did I give you here?
Close 9 hours.
What do I have here? Before I even do anything,
Unfortunately.
they gave me, stop, guys. Quit being negative. Change your attitudes. What did they give you in these tables? X's, Y's, and what's the bottom one?
X, Y.
XY. And what does XY equal? K.
Yeah.
So all you're doing is finding a constant of variation.
They're all equal 12.
Okay, so let's read what top is. An inverse variation is a relationship between two variables such that one variable increases, the other decreases proportionally. Okay? Is y equals k over x, is this a ratio? Is a ratio a proportion?
Yes.
Is it a fraction?
Yes.
Yes. That's all it's saying. As one increases, the other one decreases. Doesn't say which one, does it? Because it could be a half or it could be 2. Because 2 is still a proportion. For two variables to represent an inverse variation, the product of x and y must be what? Constant, because k is the constant of what? Variation. So if it is not constant, is this an inverse variation? No. So 1 times 12?
12. 12 and 12 and 12 and 12.
Do they all have to be the same?
Yes. Ow. Yes, they do.
They have to be
Never mind.
constant.
The next one
So
is
this is inversely related, right? So this one would be what? 20,
not inversely related.
34, 42, 44, 40, and 30. Okay, as soon as I got these two, do I have to keep going?
No.
No. But should you keep going just to check and make sure you know how to multiply? Yeah. So are these inverse related?
No.
No. Because K equals XY and K is the constant of variation. So if it's not constant, they're not inversely related. This is just working backwards. So you tell me if these two are inversely related.
Why does it give us the ugly numbers?
I'm here to support you. I think you can multiply by 2, 3, 4, 5.
No, the bottom numbers there.
It's okay. You can do it. I believe in you.
I appreciate that.
I'll tell you the answer for the first one. 25.5.
So it's all. Oh. wait.
Alex, you're supposed to be doing this. You're supposed to be finding XY. And XY.
Fine.
I'm not using a calculator either. Honestly, the only
No,
bad
they're not
ones
bad.
that are bad is this one.
Mm-hmm. If this one like ruins everything, I'm gonna be so mad.
Yeah, I don't like it when. So did you guys get 25.5?
Yeah.
So are they inverse related?
Yep.
Yes.
The next one's not gonna be.
Well, maybe it is.
You can just tell.
No, this is 19.8 and it's 27.5.
Maybe you just can't multiply.
Oh, I can multiply.
Okay, 3 is 8, so 19.8.
Mm-hmm.
And then 5 and 27.5.
Yep.
Okay, so if I get one more that doesn't match, am I going to keep going? No. So I get 8, carried 2 is 30.
Already dead.
But this still isn't that bad. 7, 2, 9, 2. And this one is 2, 4, 2. You guys remember your 11 trick?
Yep.
1, 4, 3. Olive, what's the 11 trick?
Like, okay. Like if you multiply.
So you have 11 times 22.
Yeah. So then
'Kay.
this is like 2, the 2 times itself, and then right.
Nope,
And-
split the
oh, really?
2
And then you
and
add.
add them together.
Yeah, that's what I just said.
No, you said times.
Yeah, because like you times it by itself, or not by like okay for it worked times by itself for this one works. I knew what I'm saying.
Okay, so your trick for 11, you separate them and add them together. So 1 and 3 is 1, 4, 3. So is this one inversely related?
No.
Not. Okay, I think I'm done for the day.
Let's go.
Yep.
Now that you're done, it's just I don't have an IP today, so.